Hello, everyone. I'm Deborah Byrd, and I am here with C. Alex Young, who is a heliophysicist at NASA Goddard Space Flight Center. And this is the Sun News of the Week. Hi, Alex.
Hello, how are you?
Good. I'm really good. Hey, Natalia, can you put that first slide back up again? Because we want to talk about it. There it is. Alex, what is this?
Well, what you're looking at out the right side sort of pointed downward is what we call a CME. That's a that's a coronagraph, which is an artificial eclipse. The sun's disk is blocked out. It's where that little white circle is, and that big puffy cloud kind of looks like a light bulb. That is a coronal mass ejection that we call a CME. Um, Coming out of the sun, and it's huge already.
I love this image because it's so clear looking. It's very pretty also. So that's our star with a disk in front of it. How big is that light bulb shaped cloud?
Well, that light bulb shaped cloud is probably about 10 or more times the size of the sun itself. So we're looking at a really huge piece of sun stuff, material from the sun that's expanding out to, you know, a million miles away from the sun, and it quickly will expand and continue to expand in the inner solar system.
Because like how many Earths can fit inside the sun? Is something like a million or something
Well,
Earths?
you can fit a million inside the sun, and then if you were to line them up around, across the sun, it's about 108 or 110.
Okay, so there's 110 Earths going across the sun, and this cloud is 10 times bigger than the sun. So it's a couple
Yes,
thousand times bigger than the Earth.
yes, it's massive. It's it's almost impossible to kind of comprehend how big it really is.
And I'm looking at the date on the bottom of this image. That left the sun today, right?
It did. It left the sun this morning, and in fact, computer models have already been produced for this particular CME, and um, right now it's expected to probably hit Mars, and it may graze Mercury, and there is a spacecraft around Mercury that's a European spacecraft called Bepi Colombo, and it will in fact graze Bepi Colombo.
Okay, but it's not coming toward Earth. So Mars and Mercury are both on the other side of the solar system from where we are right now. So it's going the other way.
Correct. Yes.
Yes. Okay. So let's, Natalia, can we have the next slide? Because we didn't just have one CME this week. We had a bunch of CMEs that started leaving the sun, and some of them did come toward Earth. So this is a model used by NASA, and the yellow dot here. There's two, you can see the yellow dot twice in this image, but it's kind of along this horizontal axis here, and it's a yellow dot to the right of the sun. That's us. That's the Earth. So what's going on here, Alex?
So you see this structure that spreads out from the sun. I'm actually going to turn my camera off because it's getting choppy again. So,
Okay. Okay.
unfortunately, um, so you see this blob expanding coming out, and it actually passes Parker Solar Probe, which is the little green square, and it almost directly impacts Earth. And the other view to the right of that is showing the side view, and so you can see that it very clearly hits Earth, because we have to remember that we're looking at a three-dimensional structure. So there's above and below the Earth, and that computer model is showing us when the CME leaves the sun and when we expect that it would reach the Earth.
And it takes a day or so, right, to get to the Earth.
Right. Takes on average about 1 to 3 days, and it just depends on how fast it's going.
And so this one that we're looking at here left earlier this week?
Yes. This one, I believe, left on the 9th, maybe the 10th, and it just reached us yesterday. Um, and many people around the world were fortunate enough to see the really amazing consequence of that CME hitting the Earth.
Well, let's have the next slide and we get to, oh, wait, well, we got to go 2 slides to see that amazing consequence. Before we get to the amazing consequence, oh, there we go. We're there. We're at the consequence of that chunk of sun stuff hitting the Earth, and that is we've had auroras for the past couple of nights, right?
Right. So what happens is that coronal mass ejection, when it reaches the Earth, it it actually has its own magnetic field within it, and that magnetic field interacts with the Earth's magnetic field, um, and it causes the Earth's magnetic field to sort of ring like a bell. It disturbs it, and what that does is it excites gases in the upper part of the atmosphere, oxygen and nitrogen, and they glow with these amazing colors, creating what we call aurora, either the northern or southern lights.
And did I don't, let's see, I think this one is from last night. How far down did they extend into the US?
Yes. So this is this is Alaska, of course. In Canada, there was a lot of observations in Canada. There was some very faint uh, images from I think California and the northern U.S. Of the lower 48 states, so the northern states. Um, but to see something this spectacular, as opposed to just sort of a glow on the horizon, you need it to be much higher up in the middle upper part of Canada, or in this case in Fairbanks, Alaska.
Yeah, so Fairbanks, that's way up there. Let's look at the next slide. And so this one is from Manitoba, I believe. This is from Mark Stewart, Stewart Mark on X. Um, yeah, this is beautiful. He's got all the reds and greens, which is just really
Yeah,
nice.
it's amazing. So one thing to point out is that the reds and greens come primarily from oxygen in the atmosphere, and then a lot of the blue colors come from nitrogen, because our air is predominantly nitrogen and oxygen.
That's so cool. And let's see one more of auroras because there's more. This one, RJ Roldan on X, he commented on this photo that he just caught that red at the top there, which is it's a really beautiful one.
Yeah, this is amazing, and I've been fortunate to see aurora that looks similar to this, because you are in fact literally under the aurora. It's sort of like a curtain over top of you, and you're looking up. If so that's a really amazing sight that a lot of people sort of look forward to getting that kind of specific viewpoint.
And so you say it's like a curtain. Is it moving?
It is. It moves quite a lot. Surprisingly so. When I, saw the aurora, it was very dynamic, much more so than I had expected it to be. It changed a lot, and it just sort of moves and shimmers. It's sort of like, again, you think of a curtain. It's like there's a wind or a fan blowing on a curtain, and you see the curtain moving. That's basically what it looks like above you,
And
except so
so
colorful.
yeah, and so last week you were telling us that that August, this past August, had the highest sunspot number of any month so far in solar cycle 2025. So we may be at this moment at the peak, approximately, of solar cycle 25. And so it's a good time to see these, right?
It's a good time, and there actually is also an aurora season, and the aurora season is based on the orientation of Earth and the Sun which is prime time when you are near the equinox, and we're getting very close to the September equinox.
We are. Oh, so this would be an awesome time. And tell us what happened on the sun this week, because it was an interesting week in terms of and let's go back. Let's go back to that slide that we skipped. Can you take us back a few slides, Natalia? Yeah, this one. So tell us what happened this week, Alex, because the week started out really slow. And then suddenly we had this X flare.
Yes, the even though we're at the near the peak of activity, we do have these sort of times, these little lull periods. And so that's kind of what we were experiencing. There wasn't a whole lot of activity, though there were a lot of sunspots. But then over the last couple of days, those sunspots have really started to produce a lot of activity. Initially, just what we call M flares or moderate flares. But then the largest flares on our scale of flares is sort of like a seismic scale, like the for earthquakes, is called an X flare. And in fact, a sunspot region that had not quite rotated into view produced an X flare yesterday, and that's what you're seeing, this big bright flash. And the interesting thing about this is because it's actually part way around, it's not actually within view. Part of this flare was blocked by the sun itself, so it probably was bigger than this X1 flare, maybe like a X2, 3, or something along those lines.
That's cool. And so the flare, is it just like a flash on the sun? It's on the
Yeah,
sun, right?
right. It's basically a flash. So the sunspots, that people may be familiar with. If you sort of ever seen pictures of the kind of yellow white sun, you sometimes see these dark spots called sunspots. And those are regions of really intense magnetic field, and those magnetic fields go up into the higher part of the atmosphere, and they get twisted up like a rubber band. And sometimes, just like when if you twist a rubber band enough, they're going to release energy. And one of the ways they release energy is comes out in the form of light. And so what you're seeing here, we call a flare, is just basically light over the entire spectrum of light, from light we see, like visible light, all the way to X-rays, gamma rays, and even in the other direction, radio microwaves.
So it's just light. So the CME that we were looking at earlier, that big chunk of stuff that was leaving the sun, is not the same thing as a flare. The flare's well, you say what's the difference between the CME and the flare?
Well, yeah. So basically, what's happening is these magnetic fields get twisted up and they release energy, and sometimes they release enough energy to produce a flare, but sometimes they not only produce a flare, but they also fling material, sun stuff, out into space, and that's the CME. So you don't
Right.
always have them together. There are times when we even see CMEs without flares, but they're related to the same phenomena. And in this case, we actually don't think that this X flare produced that there was a CME associated with it.
Yeah, it's interesting though. In a second, we're going to get to our final slide, which has to do with what might be coming up for us on the sun. But before we go there, I wanted to say that it's interesting about what happened this week, because it did seem so calm earlier in the week. And now when I think about that, it was like all those magnetic fields twisting the way you described, like a rubber band, because of course the sun doesn't care about our days or weeks, right? Like it's just doing its
Right,
own 25-day
right,
rotation. So there's all those magnetic fields on the sun twisting away there, for what seemed to us like a couple of days. And then suddenly blammo, and we've just got this X flare. We've had like, how many M flares were there today and yesterday? I'm not sure, but it seemed like it was
oh,
a couple of dozen, or
probably, well, M flares, we probably had maybe 10 or more, but then the smaller flares, which is the smallest size we see right now, is called a C flare. And there have been, maybe 50 or more of those. So
Oh,
you
wow.
kind of see on scales of 10. So if you see 100 C flares, you might see 10 M flares and one X flare. So the bigger they get, there's the less you're going to see of those larger flares.
Okay, so let's talk about what might be ahead. So we've had a lot of flares in the past few days, and we've had chunks of sun stuff, CMEs, leaving the sun, hitting Earth's magnetic field, causing auroras. And if we could go to the last slide, please, Natalia. There we go. So we also have this phenomenon on the sun, coronal holes. Tell us about those.
Yes. I love coronal holes. It's sort of underappreciated. They're not as flashy as these flares and CMEs, but coronal holes are actually areas where the magnetic fields open, they flow out into space. And what that means is it allows particles to easily flow out in space. So all of that glow you see on the sun is because their magnetic fields sort of holding down parts of the sun's atmosphere. And that allows them to glow. They get super hot and they glow. And so we see that glow. But there are a few places where those magnetic fields don't hold the stuff down and the stuff just flows out much faster into space. And so there's not as much stuff there to glow. And so they look kind of black. Um, and what that also means is there are areas where there's this stuff flowing out is called the solar wind. It's a stream of solar material. And those coronal holes are where it comes out very quickly. And so as it rotates around, it's kind of like a fire hose. And if it's on the right place, then it'll rotate and eventually that fire hose will be pointed to the earth. And that means that this solar wind, this fast solar wind, will flow past the earth. And that's exciting because while not as powerful as a CME, that can also cause aurora.
That's so cool. And I love this word that Alex and another gentleman named Raul Cortez, every day at earthsky.org, they put together a sun update. So if you want to come to earthsky.org, you can see Alex and Raul's sun update. It's called Sun News, and they update it every morning faithfully. It's amazing. And they often use the word geoaffective. So I normally don't like jargon, but I just love this word for some reason, that these coronal holes will soon become geoaffective.
Right. It means they're going to affect the Earth, geo for Earth, and it is a bit of jargon, but it's a term that we love because it's easy to describe what's happening. If those coronal holes are in the right place and that big spray of solar wind is going to hit, then that means that it's a geo-effective coronal hole.
Oh, that's so awesome. Okay, Alex, thank you. So started out as a calm week on the sun, ended up as a very exciting week with amazing auroral displays and even an X flare. We hope you will come back and join us next week for our Sun News of the Week every Friday at 12:15 Central Time or 17:15 UTC. And we also hope you'll come back on Monday because we've got an awesome live stream that's going to be with Jonathan McDowell, who knows all about satellites and space trash in orbit, which is a
Oh, that sounds
big,
cool.
yeah, big subject. So Jonathan's going to be with us on Monday, 12:15 Central or 17 UTC. We hope you'll join us then. Thank you, Alex.
Thank you.